Hello everyone, I welcome you all to this video, right, wherein we will be covering one more concept from the topic ERPV, simple equation, ratio, proportion, variation. So the concept that we will be discussing today shall be useful in your exams like CAT, ZAT and others, right. And for a more detailed learning, right, please do get in touch with your closest center, right, wherein we offer a variety of courses, right. If you are planning to do your MBA, we are the proved national players, right, who help students with their competitive exams preparations, right. Let's get started with the session today. So in today's class, the topics or the concepts that I have brought in front of you are typically some methods of dealing with problem solving. So for example, I'll not be taking up a particular area as such. For example, if you see a question like this, you can just pause the video at this moment, right, and try out this question on your own, right. We shall try to solve this question in a while, right, but before that you try it out yourself. Take 2 minutes, try it out yourself and see how would you approach this question, right. I, as part of this video, will be continuing with the discussion here, right. You can continue watching it once you are done with your attempt, right. So the question basically is like this. You have two equations involving three variables, right. Something like you have a1x, just a minute. You have a1x, b1y, c1z, three variables is equal to d1, one equation given to you, and similarly you have a2x, b2y, c2z is equal to d2, and if you will see, he is now asking you to find out a3x plus b3y plus c3z will be how much. He has given you these two and he is asking you to find out the third combination of variables. Now that is what is happening here in the problem. If you read it, I'll just clean this all once, right. So if you read it, it says the combined cost of 4 apples, 7 oranges and 10 bananas, three variables, apples, oranges, bananas, is 98. The combined cost of 13 apples, 9 oranges, 5 bananas is 236. What will be the combined cost of 1 apple, 1 orange and 1 banana? So he's given you two equations in three variables and then he's asking you to find a combination of the three variables. That is what essentially it is. Now how do we tackle that kind of problem is, let's take an example for that. See, observe the following question. X plus 3y plus 2z, say it is equal to 14, equation 1 given to you, okay. And second equation is 3x minus y plus 4z. 12. This is the second equation given to you. And then the question is, just a minute, 3, 12, let's change this slightly. Right, let's have a different number here. 16, let's put it. Right, let's put it 16. Now these are two equations given to you, and let's say then he's asking you to find out the value of x plus 2y plus 3z will be how much. Right? See, right now when I am trying to frame this question out here, I personally do not know whether this will work out or not. That is, by using these two, can I really find this or not? I don't really know. Let's check it together and I'll just try to teach you the method. How do we check that out, right? So we check it out on the basis of the following assumption that we make. So the assumption goes like this. We say, I don't really know if I can get this combination using these two equations. So let's make an assumption that by multiplying equation 1 with some constant, say a, some variable a, constant or variable, some value a, second equation by b, I get the third combination. I am assuming this by multiplying 1 with a could be 2, minus 2, plus 5, whatever, and multiplying second equation by b, adding them, I am getting 3. the third required expression. This is the assumption that I am making, right? If this assumption is true, what should happen? The corresponding coefficient of x will become how much? So we are multiplying this by a. So it will be a. We are multiplying this by b. It will be 3b. If the coefficient of x is going to be a plus 3b. Similarly for y, the coefficient is going to be 3a minus b. And for this, it's going to be 2a plus 4b. Z. Okay? And this should be equal to what? This should be equal to the third expression, which is x plus 2y plus 3z. If this assumption is correct, that is this left hand side is equal to right hand side, then the coefficients of individual variables should match, meaning a plus 3b should be equal to coefficient of x, 3a minus b should be equal to coefficient of y, and similarly 2a plus 4b should be equal to coefficient of z. Now, how do we check whether these equations are satisfied or not? Simple. You take any two equations, solve them, any two of your choice. Solve them. For example, if I take the first two, let's multiply second equation by 3 and add them. So when I do that, 3 into 3a, 9a plus a, 10a. 3b minus 3b cancels out. This is going to be 3 into 2, 6 plus 1, 7. So then that implies a is 7 by 10. Now when a is 7 by 10, please note what will be b? So b will be equal to 1 by 10 when you solve it. 7 by 10, b will be 1 by 10, you will get the values. Now what we need to do is, after we get the value of a and b, check whether these values of a and b satisfy the third equation or not. Because if the assumption is accurate, correct, then coefficient of x should be equal to 1, coefficient of y should be equal to 2, and coefficient of z should be equal to 3. Let's verify this. So when you do that, so 2 into a, 2 into 7 by 10 plus 4 into 1 by 10, is it equal to 3? It's not equal to 3. It's not. So that means this equation is not satisfied for these values of a and b. So that graphically it means the three lines are as follows. They form a triangle, they are not concurrent lines. In this case, whatever solution set you get from the first two equations should satisfy the third equation also. If it is not satisfying, then that means this particular expression will have no particular value, no fixed value. So my answer in that case should be cannot be determined. But just imagine, what if these values of a and b are satisfying the third equation? Say for example, this instead of 3 had been, how much do we get there? 18 by 10, 1.8. Then we say that the values of a and b are satisfying the third equation also. Then the three lines will be as follows. They will be concurrent. They will have a common solution. Now, if they have a common solution, then we can definitely get the value of this expression as first equation multiplied by a, which is 7 by 10, 14 into 7 by 10, plus second equation multiplied by b, which is 1 by 10, 16 into 1 by 10. Right? Now, when you simplify this, 98 and 16, 114 by 10 will make it 11.4. So we'll get the value of this particular expression out here if you do it like this, right? If you do it like this. I hope the point is clear. If you are able to get the solution for this third equation using the values of a and b, then we get a solution for this combination. If these values of a and b are not satisfying the third equation, then the answer shall be CBD. But as you can see, the process that we have right now is extremely long. So what we shall be doing for that is, there is a shortcut that we have in some special cases. Let me explain the shortcut using the following example. Now if you look at this, the cost of 4 apples, 7 oranges and 10 bananas is 98. The combined cost of 13 apples, 9 oranges and 5 bananas is 236. What will be the combined cost of 1 apple, 1 orange, 1 banana? So there is a small trick involved here. Observe this. So this question is similar to what we did some time back. So 4 apples, 7 oranges, 10 bananas is 98. 13 apples, 9 oranges and 5 bananas is 236. What will be the cost of 1 apple, 1 orange and 1 banana? Okay. So, similar question, but here we can apply a trick. So, the trick works as follows. Observe. First thing that you need to observe is that this is very special case, right? This doesn't work always. If it doesn't work, then you already know what to do. The thing that we have done some time back, right? You take the variables as A and B, you make an assumption, you try to compare the coefficients, you find the values. That's the process. But this trick works only when the coefficients are in AP, arithmetic progression. Please notice, here if you will see, the coefficients are having a common difference of 3, plus 3 in fact, right? Here the coefficients are having a common difference of -4, right? So, plus 3 and -4 are the common differences. They are both in AP, the coefficients of both the equations. If that is so, what do? Is step 1 is this, you identify whether they are in AP or not. Step 2 is you cross multiply the common differences. So, when you cross multiply, what do we get? This 3 should come here, this 4 without the sign should go there, cross multiply, right? Then what do you need to do is the second step, cross multiply. Third step is, depending on the signs of the common differences, if they have the same sign, then you subtract the two equations. If they have opposite signs, then you add the two equations. So, right now for example, they have opposite signs, so we shall be adding these two equations. Let's do that. So, when you do 4 into 4, 16, 13 into 3, 39. 39 and 16 will give you what? 55 apples. 4 into 7, 28. 9 into 3, 27. 28 and 27 is 55 oranges. 4 into 10, 40. 3 into 5, 15. 15 bananas. Sorry, 55 bananas. Should be equal to what? 4 into 98, 392. 236 into 3 is 708. So, when you take 55 common, you will get 1 apple, 1 orange and 1 banana, as when you add these two, it is going to be 1100. And thus, the cost of 1 apple, 1 banana and 1 orange is going to be equal to 1100 by 55, which is 22 rupees. So, in this particular trick, you can save a lot of time in making that assumption, solving those equations, checking whether they satisfy the third equation or not, by simply following the 3 steps. What are the 3 steps? Step 1 is check whether the coefficients are in arithmetic progression or not. Step 2, whatever are the common differences, you cross multiply. And step 3 is, after you cross multiply, depending on the signs of the common differences, if they have opposite signs, one plus and one other minus, then you add. If they have same sign, both minus or both plus, then you subtract. You shall always get your answer, but there is one more thing to remember, one more thing to note down. In this process, by using this technique, you will get the answer only for 1 apple, 1 orange, 1 banana type of questions. If this had been 11 oranges, you may not get the answer. This will not work, this trick will not work. So, this trick will work only in case the coefficients are the same for all the 3 variables. I'll just make a note of this point also. So, this is one small trick that I wanted to share as part of this video. Okay. So, this is one thing that we want to discuss. One more is this, you can just pause the video now and try out this question as well. We'll start the discussion anyways. A person started with X rupees and Y paise. He spent 14 rupees and 42 paise. Finally, he is left with Y rupees and 2X paise. Find X plus Y. So, the way to solve this problem comes under the concept of something called as carryover concept. So, what is that carryover concept? Let me explain briefly with a small example. So, when I want to subtract 36 and 19 from 36, how do we do that? We say that 6 minus 9 is not possible. So, what do? We borrow 1 from 3. So, this 1 in 3, when it comes to the 6, it will be multiplied by 10, right? Because this is tens place. So this 1, when it comes here, it becomes 10. 10 plus 6 is 16. 16 minus 9 can be done. Now from here we have taken 1, so it will become 2. 2 minus 1. This is how we do it, right? I am sure all of us know this. Now a similar concept will be used here also, carry over. So what is the amount he started with? He started with X rupees and Y paise. How much did he spend? 14 rupees 42 paise. How much is he left with? He is left with Y rupees 2x paise. Correct? Now here please notice, if I look at it in standalone basis like rupees separately and paise separately, I may say like this: I started with Y paise, I spent 42 paise, I am left with 2x. So that means Y minus 42 should be equal to 2x. But here comes the problem. I don't really know whether Y is greater than 42 or less than 42. For example, imagine if Y is 58. If Y is 58, then 58 minus 42 can be done easily without any problem. But if Y is, let's say, 24, then 24 minus 42 cannot be done easily. So in such a case, I'll have to take a carry, right? So thus I cannot simply subtract these two and say is equal to 26, 2x, subtract these two and say it's equal to Y. We can't really do that. So how do we check whether a need for carry is there or not is, observe. Can we say, since we are talking about here 2x paise, now this 2x, since we are talking about paise, will have to be less than or equal to 99 or not? Because I cannot write 100 here, right? 100 paise will make 1 rupee. We'll write 1 rupee and 0 paise. 100 paise has 1 rupee and 0 paise. 100 paise we don't write it, right? So 2x should be less than or equal to 99, we can say. So that means x should be less than or equal to 99 by 2, which is nothing but less than or equal to 49.5. Now what does this further mean? I started off with some amount which is less than or equal to 49.5. So something like 48 rupees, 49 rupees, 45 rupees, something like that. From that I subtracted 14 rupees. I'm just going in round figures. I'm not even looking at 42 paise there or not. From 49 rupees something, I subtracted 14 rupees. So can I say at best, I can be left with 49 minus 14 is 35. So I may say the value of Y will have to be less than or equal to 36 or not. I'm including 36 also. Maybe it's not even possible, but Y will be definitely less than 40, we may say. We are sure about it, right? Because Y is less than or equal to 36. How did we get this? I started with some amount less than or equal to 49.5. So less than or equal to 50, let's say. I spent 14 rupees. 50 minus 14, I'll get at best 36. So thus the value of Y has to be less than or equal to 36. Now the moment I say Y is less than or equal to 36, can I say when I subtract 42 out of it, I definitely need to take a carry, right? So thus when I take a carry from here, 1 rupee here will become 100 paise here. So what will be the equation like for paise? So when you look at the paise equation, it's going to be Y plus 100. Initial paise I had, I spent 42 out of it, I am left with 2x. So when you solve this, Y will be equal to 2x minus 58. This is what we'll get. Let's write down the equation for rupee. I am now left with x minus 1 rupee, out of which I am subtracting 14 rupees. I should be left with Y. So that means here I'll get Y as x minus 15. So I have two equations in two unknowns. Let's try to eliminate Y by replacing x minus 15 here. So when I use these two, what do I get? X minus 15 should be equal to 2x minus 58. When you solve this, you'll get the value of x as 58 minus 15 is 43, right? 43. So that means I started with 43 rupees. Now if x is 43, what will Y be? Y is going to be 43 minus 15 is 28. So that means, I'll just clean this. That means what? I started with 43 paise, 43 rupees and 28 paise. I spent 14 rupees and 42 paise. So when I subtract this, I'll get what? 86 here. And 42 minus 14 will give you 28 here. And please notice this 28 was nothing but Y. And this 86 was nothing but 2 into 43, 2x. Everything matches. So these are absolutely right values for x and y. Now what is he asking us? Find x plus y. So my answer clearly is 43 plus 28, which will give us what? 71. This is going to be our answer for this question. So the concept that we have discussed now is called as carryover concept, right? So it's very useful because without this concept, you will have to deal with one equation involving two variables. If you would have given it a try, you would know it. So you'll have to go for something called as special equations and all, which will be a very lengthy, slightly more complicated approach than this. Now moving on. So with this, we have come to the end of the video here, right? I hope you have followed the two types of questions, right? So for more such questions, please ensure that you don't fail to subscribe the channel, right? Please do that. On that note, let me end the video here. Thank you and all the very best.